Hello everyone, this is Siraj Khan. Welcome you all on behalf of Department of Information and Technology of Professor Ram Meghe College of Engineering and Management, Badnera. In today's lecture, we are going to start first unit of Engineering Mathematics 3, which is ordinary differential equations. Mostly, we are going to deal with higher order linear ordinary differential equations here. So first of all, we will see detailed syllabus or topics which are covered in this unit. So in the starting, we will see introduction. After that, first major topic of the unit, it is complementary function, which is a part of solution, complete solution of differential equation. Next one, particular integral. Again, it is a part of complete solution. After that, and a special method, which is method of variation of parameters for solving differential equations. After that, Cauchy's linear differential equation. And the last one, Legendre's linear differential equations. So these are the complete topics which we are going to cover here. Starting from introduction. Ordinary linear differential equations. So first of all, we will see definition of ordinary linear differential equation. What is meant by ordinary linear differential equation? So a differential equation in which power of derivative is 1, power of dependent variable is also 1, they are not multiplied with each other, means derivatives and dependent variables, or derivatives and derivatives. So they are not multiplied with each other, and their coefficients are constant. So this type of differential equation is known as ordinary linear differential equation with constant coefficients. So from here onwards, ordinary linear differential equation, we will also call it as a just linear differential equation, LDE. Okay. For example, k1 d3y by dx cube plus k2 d2y by dx square plus k3 dy by dx plus k4y equals to capital F of x, where k1, k2, k3, and k4 are constants. So this is an example for ordinary linear differential equation with constant coefficients. We can see that coefficients of derivatives and dependent variable are k1, k2, k3, and k4. It means that it is a differential equation with constant coefficients. And all the derivatives are ordinary, d by dx operator d by dx is used here. It means that derivatives are ordinary. Next thing, it is linear also, because power of each derivative it is 1, and power of dependent variable it is also 1. Dependent variable is here y. So y का power यहाँ पे 1 है, और derivative का जो power है वो भी यहाँ पे 1 है. So power of derivatives is 1, power of dependent variable is 1. There is no multiplication of derivatives and or dependent variables. So that's why we will call it as ordinary linear differential equation with constant coefficients. Now moving forward, its complete solution is given by the complete solution of this type of ordinary linear differential equation with constant coefficients. It is given by CS equal to CF plus PI. This is the formula. CS equal to CF plus PI, where CS stands for complete solution, CF it stands for complementary function, and PI it stands for particular integral. So whenever we are going to calculate complete solution of this type of differential equation, so there will be two parts of the solution. First part it is CF, means complementary function, and second part it is PI, means particular integral. So before going to the actual complete solution of differential equations, first we will see methods for finding CF, or how to calculate complementary function. Okay. Now before that, before moving forward, there is one major concept of operator D. Operator D, it is nothing but a differential operator. It is a differential operator given by capital D, it is equal to d by dx. So as I told you earlier, operator D, it is a differential operator. Means there are several ways for denoting derivative. Somewhere we use the notation for derivative of y as dy by dx. Somewhere we used it as y dash also. And somewhere we can write it as y1 also. And similarly, we can write it as capital D operating on y. This is again a method for denoting a derivative. Capital D operating on y, it means that we are taking derivative of y with respect to x. So capital D, it is a differential operator and its value is d by dx. Similarly, for second order derivative, we can use capital D square, which means d2 by dx square. For third order derivative, we can use capital D cube, which means that d3 by dx cube, and it will be continue and so on. Okay. So capital D is nothing but a differential operator. Now, somewhere if you want to write dy by dx, if you want to write dy by dx, then we can write it as capital dy. If you want to write d2y by dx square, then we can write it as capital D square y. If you want to write d3y by dx cube, then we can write it as capital D cube y, and it will be continue and so on. Now, therefore, using operator D, equation 1 can be written as. Now, equation 1, which you have seen in previous slide, the example for ordinary linear differential equation with constant coefficients. So, using operator D, it can be written as. So, before writing that equation, I will show you that equation again. Yes, this is the equation number 1. Now, we want to apply here operator D. So, if you want to apply here operator D, then first derivative d3y by dx cube, it will become capital D cube operating on y. Next, d2y by dx square, it will become capital D square operating on y. Next, next dy by dx, it will become capital D operating on y. And last dependent variable here y as it is. So it means that now equation 1 will become k1 into d3 d cube y plus k2 into d square y plus k3 into dy plus k4y equal to capital F of x. So therefore equation 1 can be written as k1 into d cube y plus k2 into d square y plus k3 into capital dy plus k4y equal to capital F of x. So this is the another way for writing or for denoting the differential equation in terms of operator D. Okay. So in this complete unit, we are only going to do all operations in the form of operator D only. In this complete unit, we are going to calculate complementary function and particular integral for getting complete solution of a differential equation. And all the operations we will apply on with the help of operator D only. So हमें कहीं पे भी अभी d by dx का format नहीं चाहिए. Means in the very starting of each and every problem, whenever a given differential equation was in terms of d by dx, we will convert that in terms of operator D, and then only we will move to the first step for finding CF and then second step for finding PI. So here we have converted equation 1 in terms of operator D. Now after that we have to simplify it. Now simplification means what we can simplify here. So first term, if you check here, it is k1 into d cube y. So d cube of y means we are applying operator d cube on function y plus k2 into d square y. Again we are taking derivative of y plus k3 into dy. Again we are taking derivative y. And last term it again contain function y here. So taking y common from left hand side, we can write it as k1 into d cube plus k2 into d square plus k3 into d plus k4 operating on function y, that is equal to capital F of x. Okay? So we have taken variable y common from left hand side, and we have to do this step in each and every problem. We need separate operator d. Operator d हमें separate चाहिए and function हमें separate चाहिए. So this bracket, this complete bracket, it contain operator d and constant. So constant अगर रहा तो that doesn't matter. So this complete bracket, it contain operator d cube, d square, d. So we will denote it as f of d, जो ऑपरेटर डी का यहाँ पे ब्रैकेट लिखा था, k1 d क्यूब प्लस k2 d स्क्वायर प्लस k3 d प्लस k4. सो जो भी यहाँ पे आपका ऑपरेटर आएगा डिफरेंशियल इक्वेशन के अंदर, so that operator can be denoted as f of d, means function of d, and operating on y, it is equal to capital F of x as it is. So these three steps are compulsory in each and every problem. First, we have to write given differential equation in terms of operator d. If it is by default written in terms of operator d, then no problem. Otherwise, we have to convert it in terms of operator d. Then after that we have to take variable y common, function y it is actually dependent variable, or we can call it a function. So we have to take variable y common from left hand side. So here we have taken y common. After taking y common, whatever remaining bracket will be there, that bracket will contain only terms of d and constant. So we can call it as f of d, means function of operator d operating on y, and it is equal to capital F of x. So this is the simplified form for ordinary linear differential equation with constant coefficients. Now, after that, topic number 1, actual topic number 1, complementary function, which is nothing but CF. So we need to calculate complementary function for getting complete solution of differential equation, because we have seen that complete solution, it is combination of CF and PI. CS का फॉर्मूला हमने प्रीवियस स्लाइड के अंदर देखा है. CS means complete solution, it is given by CF plus PI, complementary function plus PI. So whenever we need solution of differential equation, it means that we have to calculate CF as well as PI, and then we have to add them to get the complete solution of that differential equation. So first we will see CF. We will only focus on CF first, and CF का concept अगर clear हो जाता है तो then we will move to the PI. Okay. So complementary function CF. Steps for finding CF. First step, consider the differential equation as f of d operating on y equal to capital F of x, जो कि हमने अभी previous slide में last में simplified equation लिखा था. f of d, it is nothing but operator, and y, it is the dependent variable, equal to capital F of x, it is a function of x. So now step number 1, its auxiliary equation is given by f of d equals to 0. Now auxiliary equation, auxiliary means supporting, so auxiliary equation means it is a supporting equation for getting the solution. Okay? So we can call auxiliary equation as supporting equation also. So auxiliary equation is given as f of d equal to 0, and f of d, it is nothing but the operator in the equation. Left hand side पे जो operator का bracket present रहेगा, that is f of d. So auxiliary equation of any differential equation is f of d equal to 0, means operator equal to 0. Okay. Now, second step, we have to find roots of auxiliary equation. We have to find roots of auxiliary equation. So this operator f of d equal to 0, sometimes it will be in the form of a quadratic equation. Sometimes it will be in the form of a cubic equation. And sometimes it will be in the form of degree 4. Okay? So if there is a quadratic equation, then there will be 2 roots. If it is in the form of cubic equation, then there will be 3 roots. And if it is having degree 4, so there will be total 4 roots. So जो भी roots equation के आएंगे हमें वो calculate करना है, and we will use calci for calculating the roots of this auxiliary equation. After that, step number 3, depending on nature of these roots, we have to write down required CF. So depending on nature of these roots, it is important. We are having different formulae for finding CF, or we are having different cases, and these cases depends on nature of the roots which we are getting here. The nature of the roots means as I told you, if you are having a quadratic equation, we will get two roots, and these roots can be real or it can be imaginary also. Okay. Similarly, if you are having cubic root equation, then we will get three roots. Again, these can be real or it can contain an imaginary root also. So as we can have some repeated value also. So depending on these nature, एक तो मेजर पार्ट हो गया कि रियल रूट हो सकता है या फिर इमेजिनरी हो सकता है, उसमें फिर रिपीटेड वैल्यू भी आ सकता है. सो दैट्स व्हाई आई एम सेइंग दैट डिपेंडिंग ऑन नेचर ऑफ रूट्स वी हैव टू राइट डाउन द रिक्वायर्ड सीएफ. अब ये नेचर को आइडेंटिफाई कैसे करना है and how we have to write this CF. We will see it in the next slide. Rules for finding CF. Case number 1. If roots are real and different. So if roots are real and different, so how we will write CF here? Let's check it. If roots are real and different. That is capital D equal to M1, M2, M3. Suppose we are having a cubic equation in operator. So we will get three roots. So suppose these three roots are M1, M2, M3. And these are real and different. All are different. First one is M1, second one is M2, third one is M3. These are nothing but an example. And real means it do not contain imaginary term I. So that's why we are calling it as real. Real means it do not contain imaginary term I. Imaginary term I अगर आता है, it means that we will have a complex root. So उसके लिए formula different है, ठीक है? So roots are real and different means जितने भी root रहेंगे वो different रहना चाहिए. If you are having two roots, so both should be different. If you are having three roots, so all three should be different. कोई उसमें value repeat नहीं होना चाहिए. So if it happens, if you are having real root and different, suppose D equal to M1, M2 and M3, then CF it is given by CF equal to C1 into e to the power M1x. It is for the first root. First root के लिए first term हमने यहाँ पे लिख दिया C1 into e to the power M1x. Means what we have done here, we have written it as C1 into an exponential term having coefficient of x as m1. Means जो आपका first root रहेगा आपको उसको exponential term के power में लिखना है as a coefficient of variable x. तो फर्स्ट टर्म हो गया C1 into e to the power m1x. सेकंड रूट के लिए सेकंड टर्म आएगा प्लस C2 into e to the power m2x. अगेन फॉर्मेट इट इज सिमिलर, ओनली वी हैव चेंज द नंबर. फर्स्ट कांस्टेंट C1 लिखा था, अभी सेकंड टर्म के लिए सेकंड कांस्टेंट C2 एंड अगेन एक्सपोनेंशियल टर्म e to the power m2x. Now second root it is m2, that's why we have written here m2x. Then third term plus C3 into e to the power m3x. Third root it is m3, so ये हो जाएगा C3 into e to the power m3x. Okay, so we are having here total three constants C1, C2 and C3. So number of constant depends on number of roots present in the equation. Number of constant depends on number of roots of operator D. जितने D के वैल्यूज आएंगे उतने कांस्टेंट इक्वेशन के अंदर आना कंपलसरी है. We have three values of D here, M1, M2 and M3. So equation के अंदर तीन कांस्टेंट आ गए CF में, C1, C2 and C3. अगर सपोज D के चार वैल्यूज आते हैं तो फिर CF के अंदर चार कांस्टेंट आना कंपलसरी है. अगर D के दो वैल्यूज आते हैं तो CF के अंदर दो कांस्टेंट रहेगी. So for example, इसका एग्जांपल मैं आपको शो करता हूँ. Suppose we are having D equal to 2 and -1. Then CF it will become. Now we are having real roots. Both are real. Imaginary term it is not present here. First root it is 2, second root it is -1. And both are different also. तो first root के लिए first term हम यहाँ पे लिखेंगे C1 into e to the power. First root it is 2, तो ये हो जाएगा e to the power twice x. ठीक है? Then second root it is -1. तो उसके लिए second term यहाँ पे आएगा C2 and into second root it is -1. So it will become e to the power -1x or -x. Similarly, Similarly, if we are having d, it is equal to 2 comma 3, then CF, it will become C1 into e to the power twice x for first root plus C2 into e to the power second root, it is 3, so it will become e to the power 3x. If suppose we are having third root also, third root suppose यहाँ पे आता है 1, so उसके लिए third term भी ऐड करना होगा, it will be C3 into e to the power 1x or e to the power x. So this is the way for writing CF, and it is the first case, case number 1. Now after that, second case, if a real root is repeated, if a real root is repeated, that is d equal to m1 comma m1 comma m1 and comma m4, it means that here we are having 4 values of d, here we are having 4 values of d, m1, and then it is repeated m1, and again it is repeated m1, and fourth root it is different. ठीक है, so if इस टाइप से अगर कहीं पे रूट्स अगर आते हैं कि if value it is repeated, then what you have to do? Just a minute, I am removing the annotations so that you can see it clearly again. Okay, so if d equal to m1 comma m1 comma m1 and comma m4, then what will be CF? So CF will be for first root. Okay, first root it is m1 and it is present for the first time. First time we are having this root m1. इसके पहले भी हमने कोई सेम रूट फेस नहीं किया है, फर्स्ट रूट है तो इसे फर्स्ट टाइम ही फेस कर रहे हैं, सो इसके लिए कुछ भी चेंज करना नहीं है, मेथड जो रहेगा वो एज इट इज रहेगा c1 into e to the power m1x. It is for the first root, c1 into e to the power m1x, because this root m1, it is present for the first time, we are dealing it with it for the first time. Now second root m1, so now it is repeated. One time we have written a term in the CF for this root, another time again it is repeated, we are facing same root again m1, तो फिर अभी हमें यहाँ पे एक चेंज करना है, मेथड वही रहेगा c1 into e to the power m1x जैसे लिखा है वही रहेगा, but we have to do here one change, and that change is we have to multiply the second term by variable x, because it is a repeated root. तो repeated root के लिए हमें एक चेंज करना है कि second term को variable x से हमने multiply करना है, and into c2 e to the power m1x, ये as it is रहेगा. We are writing second term, we are writing CF for the second root, तो उसके लिए constant हो जाएगा c2 and exponential term e to the power m1x again, because root it is m1, तो इसमें exponential term में कुछ change नहीं होगा, it will be e to the power m1x. The only change is we have multiplied this term with variable x due to repeated root. Okay, then third root it is again m1, means फिर से repeat हो गया, यहाँ पे one time repeat हुआ था, यहाँ पे second time फिर से repeat हो गया. अभी फिर से अगर repeat होता है तो again we have to multiply the previous term by x. One time repeat हुआ था तो हमने फर्स्ट टर्म को x से मल्टीप्लाई किया था, मींस प्रीवियस टर्म को जो था हमने x से मल्टीप्लाई किया था, अभी सेकंड टाइम फिर से रिपीट हो रहा है, सो नाउ वी हैव टू अगेन मल्टीप्लाई बाय x टू द प्रीवियस टर्म, सो इट विल बिकम x into x as x square, or we can call it as, if root it is present for the first time, then we will write it as it is. If it is repeated for one time, so we will multiply it with variable x. If it is repeated for two times, then we will multiply it by x square. टू टाइम्स रिपीट हुआ है, दैट्स व्हाई हमने यहाँ पे x स्क्वायर से मल्टीप्लाई किया है, एंड इनटू c3 e to the power m1x, इट इज एज इट इज. थर्ड कांस्टेंट है तो इसके लिए कांस्टेंट c3, एंड एक्सपोनेंशियल टर्म में तो कुछ चेंज नहीं होगा, इट विल बी एज इट इज e to the power m1x. ठीक है, सो अगेन आई एम रिपीटिंग दिस स्टेप. Okay, so first root m1, we are dealing with this root for the first time, so we have written it as c1 into e to the power m1x. कुछ भी change इसमें हमने नहीं किया है. Second root, again it is m1, so now it is repeated for one time. m1 already हमारा हो गया था. Now it is repeated for one time. One time repeat हुआ है means we have to multiply it by x to the power 1. So second term को हमने यहाँ पे x to the power 1 से multiply कर दिया into c2 into e to the power m1x as it is. Then again it is repeated for second time. Second time यहाँ पे फिर से repeat हो गया. Second time अगर repeat होता है तो now we have to multiply it by x square. Second time repeat हुआ है, that's why we have to multiply it by x square and into c3 e to the power m1x as it is. Okay, so real root के लिए formula तो same है. Constant, जो भी constant का number रहेगा c1 c2 c3 and into e to the power that root जो भी रहेगा m1 m2 m3. So suppose it is m1x. So real root के लिए formula यही है, सिर्फ हमें change क्या करना है. If root is repeated for one time, so we have to multiply by x. If root is repeated for two times, then we have to multiply it by x square. And if root it is repeated for three times, again, then we have to multiply by x cube and it will be continue and so on. ये method जो है, ये process जो है वो continue रहेगा. अब यहाँ पे जो fourth root है, it is a different. यहाँ पे m4 आ गया. पहले m1 लिखा था, अभी ये m4 हो गया. तो m4 now it is different. No doubt it is real. Imaginary term यहाँ पे लिखी नहीं है. So it is real, but it is different. तो रूट डिफरेंट हो गया. इट मींस दैट कि अभी फिर ये डिफरेंट रूट के लिए हमें x से मल्टीप्लाई करना नहीं है. डायरेक्टली वी विल राइट द फोर्थ टर्म एज c4 into e to the power m4x. ठीक है, फोर्थ रूट इट इज डिफरेंट हियर, तो उसके लिए फोर्थ टर्म यहाँ पे हमने ऐड कर दिया c4 into e to the power m4x. सो वेरिएबल x से मल्टीप्लाई कब करना है? इफ यू आर गेटिंग रिपीटेड रूट, रिपीटेड वैल्यू, देन एंड देन ओनली वी हैव टू मल्टीप्लाई इट बाय x. वन टाइम रिपीट हो रहा है तो x से मल्टीप्लाई करना है. टू टाइम्स रिपीट हो रहा है तो x स्क्वायर से मल्टीप्लाई करना है. थ्री टाइम्स रिपीट होता है तो x क्यूब से मल्टीप्लाई करना है. एंड इट विल बी कंटिन्यू. ओके, सो आई एम रिमूविंग द एनोटेशंस. Okay, so I will show you an example for this second case. If d equal to 2, 2, only two roots are there and both are repeated, and no doubt these are real. Imaginary term is not present here. So CF, it will become first root, it is 2. We are dealing it for the first time only. So इसमें कुछ change करना नहीं है. It will be C1 into e to the power twice x. ठीक है. Second root, it is again 2 and now it is repeated for one time. Already first time हमने लिया था, अभी ये वापस से repeat हो गया. And it is repeated for one time means we will multiply it with variable x and into C2 e to the power twice x again. ठीक है, is it clear? अब इसके आगे अगर फिर से next root अगर 2 आता है, so now it is repeated for second time. So next term को हमें x square से multiply करना होगा and into C3 e to the power twice x again. ये हो गए तीन रूट्स, C1, C2, C3, तीन कांस्टेंट आ गए. फोर्थ रूट भी अगर फिर से 2 आता है मींस इट इज रिपीटेड फॉर थर्ड टाइम नाउ. सो फिर अभी x क्यूब से मल्टीप्लाई करना होगा एंड फोर्थ रूट है तो उसके लिए कांस्टेंट C4, एक्सपोनेंशियल टर्म e to the power twice x again because root it is 2 and this will be continue. जितनी बार रिपीट होगा उतनी बार हमें x का पावर इंक्रीज करते जाना है और टर्म्स को मल्टीप्लाई करते जाना है. Okay, so this is the way for writing repeated roots, real and repeated. Real रहना चाहिए और उसके बाद में फिर repeated होना चाहिए. Now third case, if roots are imaginary. If roots are imaginary means root contain an imaginary term. So imaginary root जब भी आएगा, so it will be in the form of a pair. Always it will occur in the form of a pair. So if there is a pair of complex roots, as imaginary means it is nothing but a complex number. इमेजिनरी रूट अगर आता है इट मींस दैट इट इज नथिंग बट अ कॉम्प्लेक्स नंबर। और इमेजिनरी रूट या कॉम्प्लेक्स नंबर जब भी आएगा डी के वैल्यू में, तो वो हमेशा पेयर के फॉर्म में रहेगा। ऐसे कभी नहीं होगा कि एक रूट इमेजिनरी आ रहा है और सेकंड रूट रियल आ रहा है। मिनिमम दो रूट्स आएंगे, वो हमेशा पेयर के फॉर्मेट में रहेंगे। एंड पेयर विल बी एज कैपिटल डी इक्वल टू अल्फा प्लस माइनस आई बीटा कॉमा M3। सो अब यहाँ पे टोटल रूट्स कितने लिखे हैं, टोटल वैल्यूज कितने लिखे हैं यहाँ पे डी के, पहले इसे चेक कर लेते हैं। वी हैव रिटन अल्फा प्लस माइनस आई बीटा। अल्फा प्लस माइनस आई बीटा मीन्स इट इज अ पेयर। one root it is alpha plus I beta, and other root it is alpha minus I beta, and third root it is M3 which is real। यहाँ पे इमेजिनरी टर्म नहीं है इसलिए मैंने इसको M3 डिनोट किया, इट इज रियल। मीन्स फर्स्ट टू रूट्स के अंदर इमेजिनरी टर्म प्रेजेंट है I। फर्स्ट रूट इट इज अल्फा प्लस आई बीटा, सेकंड रूट इट इज अल्फा माइनस आई बीटा, एंड थर्ड रूट इट इज रियल। सो फर्स्ट टू रूट्स जो है इस ये हमेशा कॉम्प्लेक्स पेयर के फॉर्मेट में रहेगा। सो इसको कंबाइनली ऐसे लिखना है अल्फा प्लस माइनस आई बीटा, ठीक है। सो इफ यू आर हैविंग अ कॉम्प्लेक्स पेयर, अ पेयर ऑफ कॉम्प्लेक्स रूट, देन हाउ टू राइट दिस CF। तो अब इसके लिए फॉर्मूला यहाँ पे चेंज है। रियल रूट के लिए फॉर्मूला सेम था, एक्सपोनेंशियल C1 इंटू एक्सपोनेंशियल टर्म, C2 इंटू एक्सपोनेंशियल टर्म, C3 इंटू एक्सपोनेंशियल टर्म, ठीक है। अभी कॉम्प्लेक्स पेयर के लिए फॉर्मूला यहाँ पे चेंज है। फॉर कॉम्प्लेक्स पेयर CF इट इज गिवन बाय CF इक्वल टू e to the power alpha x in bracket C1 cos beta x plus C2 sin beta x. This is the formula for writing CF of a complex pair. This is the formula for writing CF of a complex pair. CF equal to e to the power alpha x in bracket C1 cos beta x plus C2 sin beta x. Now, this term contain two constants C1 and C2, means we have written this formula for two roots। दो कांस्टेंट आए मींस दो रूट्स के लिए हमें दो कांस्टेंट चाहिए, तीन रूट्स के लिए तीन कांस्टेंट चाहिए। तो ये ब्रैकेट के अंदर, ये फॉर्मूले के अंदर यहाँ पे दो कांस्टेंट लिखे हैं C1 एंड C2, मींस we have written this formula for two roots alpha plus I beta and alpha minus I beta। That's why जब भी कॉम्प्लेक्स नंबर आएगा, जब भी कॉम्प्लेक्स रूट आएगा, तो वो हमेशा पेयर के फॉर्मेट में ही रहेगा। कॉम्प्लेक्स नंबर हमेशा पेयर के फॉर्मेट में आएगा, कॉम्प्लेक्स रूट हर बार पेयर के फॉर्मेट में ही आएगा। एक सपोज अगर ऐसे आता है 1 प्लस आई, तो सेकंड रूट आपका कंपल्सरीली 1 माइनस आएगा। अगर सपोज फर्स्ट रूट अगर आपका आता है कि 2 प्लस रूट 3 आई, तो सेकंड रूट विल बी कंपल्सरीली 2 माइनस रूट 3 आई। सो इट विल ऑलवेज ऑकर इन द फॉर्म ऑफ अ पेयर, ठीक है। नाउ अब इसे लिखना कैसे है, तो e टू द पावर अल्फा x। So in exponential term, we have placed here alpha as the coefficient of x, e to the power alpha x. So alpha it is the real part in that complex number. Then in bracket C1 cos beta x plus C2 sin beta x. So beta it is imaginary part in complex number. Beta it is the imaginary part. Alpha it is real part and beta it is imaginary part. So अब इसका example check कर लेते हैं कि how we are going to apply this formula. Before that, just a minute. एक third term यहाँ पे बाकी है. Third term yes, third root it is M3 which is real and different। हमने दो रूट के लिए फॉर्मूला तो लिख दिया, फर्स्ट टू रूट्स आर कॉम्प्लेक्स, तो उसके लिए आ गया e to the power alpha x in bracket C1 cos beta x plus C2 sin beta x। थर्ड रूट it is remaining here and which is real and different, तो उसके लिए हमें as it is previous method यूज करना है जो हमने यहाँ पे देखा था। रियल एंड डिफरेंट के लिए सिर्फ कांस्टेंट का नंबर चेंज हो जाएगा। टू कांस्टेंट्स already written here, C1 and C2। So now we will use third constant plus C3 and e to the power M3x for third value which is M3. Okay, so now I will show you an example. If suppose we are having d equal to 1 plus minus I, it is a complex pair of roots, so we have to compare it with alpha plus minus I beta जिसके लिए हमने फॉर्मूला लिखा है। फॉर्मूला हमने alpha plus minus I beta ये रूट के लिए लिखा है। So compare these two complex numbers. By comparing, we will get here real part alpha it is equal to 1 and imaginary part beta also it is equal to 1. Beta it is the coefficient of I. So here coefficient of I it is 1, तो beta का value भी यहाँ पे 1 रहेगा। So therefore CF will become e to the power alpha x in bracket C1 cos beta x and plus C2 sine beta x. Now substitute here values of alpha and beta. So CF, it will become value of alpha is 1, value of beta it is also 1. So it will become e to the power x. Alpha का value 1 हो गया. In bracket C1 cos beta x. तो beta का value 1 है, तो फिर से ये हो जाएगा सिर्फ cos x and plus C2 sin again beta x. So beta x will become only x. Value of beta it is also 1. So this is the CF for the root alpha plus minus I beta. Okay. Now we will take an example for finding CF only. अभी PI second जो part है PI उस पे हमने कुछ भी focus नहीं किया. We are only dealing with CF. जब तक CF clear नहीं होगा तब तक हम PI calculate नहीं करेंगे. Because first part of each and every problem is CF. And compulsorily complete unit में हर problem के अंदर आपको CF calculate करना ही है. Okay. So find CF of following differential equation. That is the first problem. We have to find CF of following differential equation. d2y by dx square minus dy by dx minus twice y equal to twice log x plus 1 by x plus 1 upon x square. Solution. It's we will as usual start with the given differential equation, which is d2y by dx square minus dy by dx minus twice y equal to twice log x plus 1 by x plus 1 upon x square. As usual, we have started with given differential equation. Now, as I told you earlier, each and every differential equation should be written in terms of operator d only. हमें कहीं भी dy by dx का टर्म नहीं चाहिए. Operator d के फॉर्मेट में ही हमें इक्वेशन को लिखना है. Okay, so convert it in terms of operator d. So using operator d, it can be written as, now first term d2y by dx square, it will become capital D square y. Second term will become minus capital dy. Third term will be as it is. So capital D square y minus capital dy minus twice y equals to twice log x plus 1 by x plus 1 upon x square. Now, after converting the equation in terms of operator d, now we have to take dependent variable y common from left hand side. यहाँ से हमें y को common लेना है. Remaining term on left hand side will be d square minus d minus 2 inside the bracket, and y we have taken it is outside the bracket. So equal to right hand side as it is. Right hand side का भी हमें कहीं पे भी use करना नहीं है. For finding CF, we will only use left hand side. The right hand side will be used for calculating PI. So अभी right hand side को ignore कर दो. We are not going to use right hand side here at this moment. So simplified operator is now d square minus d minus 2. That is the value of simplified operator, which is nothing but capital F of d. So to find CF, its auxiliary equation is given by f of d equal to 0. It is the formula for auxiliary equation. As I told you earlier, auxiliary equation is given by f of d equal to 0 means operator का जो bracket रहेगा उसे हमें लिखना है equal to 0. So f of d का value यहाँ पे है d square minus d minus 2. It is the value of f of d. So it will become d square minus d minus 2 equal to 0. Now it is a quadratic equation in terms of d. So we can get its two roots. So values of d will be d equal to 2 and minus 1. And again, we have to use calci for calculating these roots. Manually भी कर सकते हैं, but उसमें time ज़्यादा जाएगा और wrong होने के chances रहेंगे. So always use calci. So we will get here d equal to 2 and minus 1. So therefore roots are real and different. For both roots are real, imaginary term it is not present, and both are different also. So CF it will become CF equal to C1 into e to the power twice x for first root plus C2 into e to the power minus x for second root, and which is the required CF. Okay. So this is the way for getting CF of any differential equation. Okay. So moving to the next problem. Find CF of following differential equation. Y double dash minus twice y dash plus twice y equal to e to the power x tan x. So as usual, we will start with given differential equation, which is y double dash minus twice y dash plus twice y equal to e to the power x tan x. Now, before starting its solution or before finding CF, कुछ भी कैलकुलेट करने के पहले फर्स्ट जो रिक्वायरमेंट है वो ये रहेगा कि वी नीड गिवन डिफरेंशियल इक्वेशन इन टर्म्स ऑफ ऑपरेटर डी ओनली, हमें ऑपरेटर डी के फॉर्मेट में ही चाहिए. So using operator D, it can be written as, so first term it is y double dash is second order derivative of y. So it will be written as d square y. ठीक है, minus second term it is twice y dash. Y dash means first derivative of y. So we will write it as 2 times dy. Then third term plus twice y will be as it is and right hand side will be as it is. So using operator D, we will write it as d square y minus 2 times dy and plus twice y equal to e to the power x tan x. Again, we are not going to use right hand side for calculating CF. We will only deal with left hand side here. So from left hand side, taking variable y common, by taking variable y common, remaining terms inside the bracket will be d square minus twice d plus 2 and operating on y equal to right hand side as it is. Now d square minus twice d plus 2, it is nothing but here operator, we will denote it as f of d. It is the value of operator, function of d. Okay. Now to find CF, its auxiliary equation is given by f of d equal to 0 and value of f of d in this equation is d square minus twice d plus 2. जो लेफ्ट हैंड साइड पे ऑपरेटर का ब्रैकेट आया था वो ब्रैकेट मैंने यहाँ पे लिख दिया. It is the value of f of d, d square minus twice d plus 2 equal to 0 as it is. Again, it is a quadratic equation in terms of d. फिर से हमारे पास quadratic equation आ गया. So quadratic equation will have two roots. So calculate its roots by using calci. We will get d equal to 1 plus I and 1 minus I. So we got here imaginary roots. That's why I told you to use calci, because if you calculate it manually by hand, so इसमें time थोड़ा ज़्यादा जाएगा. So d equal to 1 plus I and 1 minus I. दो रूट्स यहाँ पे प्रेजेंट है. फर्स्ट रूट इट इज 1 plus I, second root it is 1 minus I. And we can see that it is a complex pair. So we can write it as in the form of 1 plus minus I. Okay. So d equal to 1 plus minus I. And it is just similar to alpha plus minus I beta. Because imaginary roots अगर आते हैं तो उसमें जो हमने फॉर्मूला लिखा है वो अल्फा और बीटा के फॉर्मेट में लिखा है. That's why जब भी इमेजिनरी रूट आएंगे उसे अल्फा प्लस माइनस आई बीटा से हमें कंपेयर करना है. सो देयरफॉर रूट्स आर इमेजिनरी. अभी जो लास्ट प्रॉब्लम सॉल्व किया वहां पे रियल रूट्स थे, यहाँ पे रूट्स इमेजिनरी आ गए. तो रूट्स इमेजिनरी अगर आते हैं तो उसके लिए हमारे पास फॉर्मूला है CF, इट इज इक्वल टू CF इक्वल टू e to the power alpha x in bracket c1 cos beta x plus c2 sin beta x. कंप्लीट फॉर्मूला मैंने यहाँ पे पहले एज इट इज लिख दिया. e to the power alpha x in bracket c1 cos beta x plus c2 sin beta x. c1 c2 दो कांस्टेंट है because we are having two roots. Okay. Now पहले कंप्लीट फॉर्मूला लिखना है, उसके बाद आपको अल्फा और बीटा के वैल्यूज को यहाँ पे सब्स्टिट्यूट करना है. So let's check what is alpha here and what is beta here. So alpha, it is the real part of the complex number, which is here 1, and beta, it is imaginary part, means coefficient of I. So coefficient of I, it is also 1. So we are having here alpha equal to 1 and beta equal to 1. So substituting these values of alpha and beta, alpha equal to 1 put karna hai. Here we will substitute alpha equal to 1, so it will become e to the power x. And here we will substitute beta equal to 1, so it will become cos px and it will become sin bx. So CF, it is equal to e to the power x in brackets c1 cos x plus c2 sin x. Okay. Cos bx will become cos x and sin bx will become sin x. So which is the required result or required CF for given differential equation. Now moving to the next problem again. Find CF of following differential equation. D cube plus thrice d operating on y equal to cos h of twice x into sin h of thrice x. So as usual, we will start with given differential equation. Now, by default, this equation, it is written in terms of operator d. The previous two problems which you have seen, in previous two problems, equation was not in terms of operator d. So first we have converted these equation in terms of operator d. नाउ हियर बाय डिफॉल्ट इट इज गिवन इन टर्म्स ऑफ ऑपरेटर टी. सो एक काम तो हमारा यहाँ पे होगा, सिंप्लीफिकेशन करने का काम नहीं है, ऑलरेडी ये सिंप्लीफाइड फॉर्मेट के अंदर लिखी है. नाउ वी विल राइट मेथड फॉर फाइंडिंग CF. टू फाइंडिंग CF we need auxiliary equation. So auxiliary equation, it is given by, auxiliary equation is given by d cube, sorry, f of d equal to 0. Auxiliary equation is given by f of d equal to 0, and value of f of d is here d cube plus thrice d. So it will become d cube plus thrice d equal to 0. Now highest power is here 3, d cube. D cube means it is a cubic equation. D cube का term यहाँ पे present है, it means that it is a cubic equation and there should be 3 roots of cubic equation. अभी आप इसको manually solve कर सकते हो by taking D common, but don't solve it manually, time waste हो जाएगा और wrong भी हो सकता है. Always we will go with calci. So for using calci, first we have to write it in a standard format of a cubic equation. अभी cubic equation का standard format क्या होता है? पहले d cube का term चाहिए, उसके बाद d square चाहिए, उसके बाद d और last में constant. तो अब यहाँ पे डी स्क्वायर का टर्म प्रेजेंट नहीं है, कांस्टेंट टर्म प्रेजेंट नहीं है, सो वी विल राइट इट एज डी क्यूब प्लस 0d स्क्वायर प्लस 3d as it is and plus 0 and equal to 0. So in this way we have written this equation in standard format of a cubic equation. Now we can solve it by using calci. अब इस पे हम calci यूज कर सकते हैं. While using calci we have to just enter the coefficients. पहले coefficient of d cube enter करना है which is 1, coefficient of d square enter करना है which is 0, coefficient of d enter करना है which is 3 and constant term enter करना है which is 0 and equal to 0. Okay, so we will get here 3 values of d cube. We are solving a cubic equation, तो अभी d के 3 values आना चाहिए, compulsorily 3 values हमें चाहिए. So let's see which values are getting here. So we will get here d equal to root 3i minus root 3i and third value is 0. First value plus root 3i, it contain imaginary term, तो सेकंड वैल्यू जो रहेगा वो कंपल्सरीली माइनस रूट 3 आएगा. इमेजिनरी टर्म अगर आता है तो वो हमेशा पेयर के फॉर्मेट में ही रहेगा. फर्स्ट रूट प्लस रूट 3 आए अगर आता है तो सेकंड रूट कंपल्सरीली माइनस रूट 3 आ रहेगा एंड थर्ड रूट इज हियर 0. सो फर्स्ट टू रूट्स कंटेन इमेजिनरी टर्म, सो उसे फर्स्ट टू रूट्स को पेयर के फॉर्मेट में लिखना है. सो रूट 3 आए एंड माइनस रूट 3 आए, वी कैन राइट इट एज d इक्वल टू प्लस माइनस रूट 3i और प्लस माइनस i इंटू रूट 3 एंड कॉमा 0, थर्ड रूट इट इज एज इट इज. ठीक है. नाउ अगेन फर्स्ट टू रूट्स आर इमेजिनरी. इमेजिनरी है मीन्स अल्फा एंड बीटा हमें चाहिए. सो वी विल राइट इट एज plus minus root 3i, we will write it as 0 plus minus I root 3 because we need value of alpha and we need value of beta. Alpha it is the real part, beta it is the imaginary part. तो यहाँ पे रियल पार्ट कुछ भी प्रेजेंट नहीं था, डेट्स वाई हमने पहले से स्टैंडर्ड फॉर्मेट के अंदर लिखा 0 प्लस माइनस आई रूट 3 एंड नाउ वी विल कंपेयर इट विद अल्फा प्लस माइनस आई बीटा. ठीक है. सो देयरफॉर roots contain a complex pair. Total 3 roots are there, plus I root 3 minus I root 3 at 0. Total 3 roots है, तो तीनों में से 2 जो है वो complex है. So roots contain a complex pair. So therefore CF it is given by CF equal to, पहले कॉम्प्लेक्स पेयर के लिए फॉर्मूला लिखना है, उसके बाद रियल रूट जो है उसको बाद में सोचेंगे. पहले कॉम्प्लेक्स पेयर के लिए लिखना है अल्फा प्लस माइनस आई बीटा. सो फॉर कॉम्प्लेक्स पेयर द फॉर्मूला इज e to the power alpha x in bracket c1 cos beta x plus c2 sin beta x. That is the formula for writing a CF for complex pair. e to the power alpha x in bracket c1 cos beta x plus c2 sin beta x. ये हो गया complex pair के लिए. And this formula contain two constants c1 and c2 means it is sufficient for two roots. बट यहाँ पे थर्ड रूट भी प्रेजेंट है. थर्ड रूट इट इज 0 एंड विच इज रियल, इट डू नॉट कंटेन इमेजिनरी टर्म. थर्ड रूट इट इज 0 एंड इट इज रियल. तो थर्ड रूट के लिए आपको एक और टर्म यहाँ पे ऐड करना है. प्लीज रिमेंबर दैट टोटल नंबर ऑफ कॉन्स्टेंट्स इन CF विल डिपेंड ऑन टोटल नंबर ऑफ रूट्स. जितने रूट रहेंगे उतने कॉन्स्टेंट C1 C2 C3 जो भी रहेंगे उतने वैल्यूज आना चाहिए. ओके. अभी आपको ऐसे लगेगा कि थर्ड रूट यहाँ पे 0 है तो उसके लिए नहीं लिखा तो भी चलेगा, ऐसे नहीं है। थर्ड रूट अगर 0 भी अगर आता है तो उसके लिए आपको यहाँ पे थर्ड टर्म ऐड करना कंपलसरी है। ओके, इक्वेशन शुड कंटेन थ्री कांस्टेंट इफ रूट्स आर थ्री, सो इक्वेशन शुड कंपल्सरीली कंटेन थ्री कांस्टेंट्स C1 C2 एंड C3। तो थर्ड रूट इट इज 0, उसके लिए यहाँ पे एंड इट इज रियल, सो उसके लिए यहाँ पे नेक्स्ट टर्म ऐड हो जाएगा प्लस C3 इंटू ई टू दावर 0x। वैल्यू 0 है तो हम यहाँ पे एक्सपोनेंशियल टर्म में पावर 0x लिखेंगे, ठीक है। सो प्लस C3 इंटू ई टू दावर 0x, इट इज फॉर द थर्ड वैल्यू। ओके, नाउ आफ्टर दैट, now we need to substitute values of alpha and beta। अल्फा और बीटा के वैल्यूज को अभी हमें यहाँ पे पुट करना है। सो लेट्स चेक व्हाट इज अल्फा एंड व्हाट इज बीटा हियर। सो अल्फा इट इज द रियल पार्ट, so value of alpha it is 0, and beta it is the imaginary part, means coefficient of I, so coefficient of I is here root 3, so here alpha equal to 0 and beta equal to root 3। So substituting these values here in the CF will become alpha equal to 0, so exponential term will become e to the power 0x in bracket, beta it is root 3, so bracket के अंदर आ जाएगा C1 cos root 3x and plus C2 sin root 3x। okay, now next term plus C3 into e to the power 0x, तो अभी ये e to the power 0x यहाँ पे लिखा है, e to the power 0x it is nothing but e to the power 0, and value of e to the power 0 it is nothing but equal to 1, तो उसे हम रिमूव कर सकते हैं। So here we are having e to the power 0x, and here also we are having e to the power 0x, e to the power 0x it is nothing but e to the power 0, and value of e to the power 0 it is equal to 1, so it will be get removed, ये exponential terms यहाँ से remove हो जाएंगे, remaining जो CF रहेगा it will be CF equal to C1 cos root 3x plus C2 sin root 3x and plus C3 only, so it is the CF for given differential equation। ओके, एंड नाउ आई थिंक अभी CF कैसे कैलकुलेट करना है ये 3 एग्जांपल से आपको क्लियर हो जाएगा। एंड स्टिल इफ यू आर हैविंग एनी डाउट, कुछ अगर लगता है तो एक बार फिर से प्रॉब्लम को रिपीट करो, कहीं पे अगर डाउट लगता है तो अगेन सी द प्रॉब्लम रिपीटेडली, 1 टाइम 2 टाइम, जब तक डाउट क्लियर नहीं होता है तब तक आप इसको चेक कर सकते हो। ओके, सो विद दैट वी विल स्टॉप हियर, एंड नेक्स्ट जो पार्ट है PI, we will take the next part in the next lecture, so with that we will stop here, thank you very much।